Everybody with me? All right, so our last section is solving polynomial equations here. So polynomial equations will have the same number of solutions as their degree. It's very similar to zeros. Okay, they're going to be closely related. Okay, so if you have something to the 5th power, there should be 5 answers. Now, they may not be 5 distinct answers because you can have like double roots on that. So some of them will be double. You also may end up with some that are imaginary. So there are multiple methods for solving a polynomial. We can graph it, which is going to be our easiest. We will be able to use Desmos on that. Factoring can work sometimes. If factoring doesn't work, we can use quadratic formula or completing the square, which you were supposed to learn in Math 2. But I don't reteach that because I usually find that most students don't remember how to do it, and quadratic formula will work with it. I love completing the square, but I don't think we have time to spend time on it. Or for higher degree polynomials, you're going to have to graph and then use, this says synthetic division. I did not do synthetic division. We can mark that out. These were Miss Martin's notes, and I didn't change this. Synthetic needs to be changed to long division. You have to learn long division whether you do synthetic division or not, and we just rely on Desmos mostly. So I did not teach you guys synthetic division. If you have friends in honors Math 3, you might see them doing this weird thing where they got like a 3 here, and they got 2, 1, 7, 4, and they do like this. 2, 3 is 3, 4, and like all that. That's synthetic division. We're not going to do that. So if you see somebody doing that, that's what that is. Okay. Method 1 is solving by graphing. The only type of solutions that show up on your graph are real solutions. Any imaginary solutions will not be visible. So if it has imaginary, there's going to be more that we have to do. But not all of them have imaginary. Some of them are all real, and we can just graph them. Okay? So whenever we graph something, it might look like this. These 2 spots would be our zeros, which are going to correspond to our solutions. Right? What would be special about this one right here? That bounces, which makes it a double. Right there. So it counts twice for that. So like for this one, you would have 3 real solutions. Even though there are only 2 distinct solutions, one of those is a double for that. Okay, now for graphing. Now, I have already shown you how to solve any equation, but then these instructions are going to be different, and I'm going to tell you why. Okay, now it will still work to find your real zeros. So if we have, I use this for any equation. Some of you used it on the warm-up this morning, right? If you have an equation and you're trying to do it with Desmos, here. Okay, if I have an equation and I'm trying to do it with Desmos, what I've told you so far was to do this. F of x equals the left side, right? So that'd be 3x to the 3rd minus 12x to the 2nd. Okay? And then what do I have to do with the other side? G of x equals, and then I put the right side of the equation, 6 minus 15x. Okay, there are a couple reasons why I don't want us to do it this way. Number 1, the graph gets crazy sometimes. Like this right here, it's hard to tell where it hits. It actually hits at, no, that's not a point because that's the x-intercept. It hits at 1 and at 2. So I think 1 and 2 are supposed to be our answers here. But it's kind of hard to see that there's two separate places from the graph. Also, if we do it this way, it's not going to let us know whether we have double zeros or not. So what we're going to do is similar, but we're going to move things around a little bit, okay? So if I want to solve by graphing, the first thing I want to do, if I'm doing a polynomial equation right here, is move everything to one side so that the equation is equal to 0, okay? So if I want to move everything to one side, I usually try to pick the side that has the highest exponent and move everything to that side. So I would need to like subtract 6 right here and add 15x to get rid of this. So I'd subtract 6, I'd add 15x. Can I put any of that together? None of it goes together because none of it has the same variable parts. They're not like terms. So I'm just going to get 3x to the third minus 12x squared. I'm going to write that plus 15x first and the minus 6 last. And this would be equal to 0 because there's nothing left on the other side. Okay, so move everything to one side. Then look at the degree of the equation, determine the number of solutions. How many solutions are we going to have for these? For this one? Okay? How many? It's going to be 3. You're just looking at that highest exponent. So you're going to have 3 solutions. Now, they may not all be real solutions, but they are going to, there will be 3. And they might not all be distinct. We could have like a triple 0 on this or a double 0 here and another one somewhere else. All right, so then we are going to graph the expression y equals or f of x equals. Do not include the equals 0. If you want to think about doing this the way we've done the other problems so far, you could do f of x equals 3x to the third minus 12x to the second plus 15x minus 6. And if we wanted to, we could do g of x equals 0. We could do left side, right side. But this is just going to be 0, which is just your x-axis, right? So what's better about doing it this way is it's easier to see the graph most of the time. And it's going to tell us whether or not we have a double 0. Okay, so I see 2 places where I cross the x-axis, or touch the x-axis right here. I've got 1 and 2. So x equals 1 is one of my solutions. But what is special about x equals 1? It's a bounce, right? So that is a double solution, or we could say it's a double solution or sometimes you'll see them say multiplicity of 2, right? So although it's only one distinct 0, it counts twice because it's a double solution. And then our other solution over here is 2, so we've got x equals 2. And we're only supposed to have 3 solutions for this one, so we don't have any imaginary solutions because it's 2 distinct solutions, but it's 3 solutions in all because this one is a double. Okay? So we found our x-intercepts. We determined their multiplicity. Step 6 we did not have to do on this problem, but if you have any solutions that are still missing, these are probably imaginary, and you will have to use a different method for that. Okay? So graphing, we just want to move everything to one side. Graph the left, graph the right, see where they cross. Okay, and the right should always be 0, so it's just the x-axis. If you don't want to graph it, you could just look for your x-intercepts. Okay? All right, so let's try this next one together. it's not all on one side, so the first thing we need to do is move everything to one side, right? So I would just move, I'd subtract that 35x squared, just make sure when it moves over to the other side, it's got a different sign. Will anything combine right there? Can I put anything together? No. So it's just going to be 5x to the fourth minus 35x squared plus 30x equals 0. How many solutions should I have for this one? 4. This is going to be 4 solutions because I have a highest exponent of 4. Okay, so then we'll go over here and graph it. On the left side, we've got 5x to the fourth minus 35x to the second plus 30x. And you need to zoom out a little bit on this or you won't get all of your answers. Okay, and we are looking for our x-intercepts. So I've got, let's see, if I click on them, it'll stay one thing. Looks like I've got x equals -3, x equals 0, x equals 1, and x equals 2 for that. Okay, I was supposed to have 4 solutions. I've got 4 distinct solutions, so I don't even really have to think about the multiplicity on these. They're all 1. This would just be my answer. Okay, you guys try 3 on your own right now. Okay, try 3 on your own. Graph here. All right. Okay, so you should move the 4x to the fourth over to the other side, which will give you a -4x to the fourth right here. And whenever I graphed it, this is what mine looks like right here. So I zoomed in and out a bunch because how many zeros should this one have? 5. And even when I zoomed pretty far out, like what I'm kind of looking for is if it like turns back up and hits over here. I'm not seeing that happen. I think my only real zeros are right here. Okay, so I have x equals negative 1.391. And I have x equals 0. Now, do they have single multiplicity, or are there any of those that are double? Okay, I'm seeing double for which one? 0. So this one is a double. It is possible that it is a quadruple, that there's 4 of them there, but it's not going to be because then it would have something about the equation would have to be. There is a chance that this one right here is a triple root. I think that's probably unlikely, but it could be. I think the most likely scenario is that we have not found all of the zeros, right? So if we're getting these two, then probably there's more zeros out there. What's probably true about the other 2 zeros? They're imaginary. So probably 2 imaginary. Now, at this point, we don't have the skills to find those imaginary. So we're just going to stop here and say there's probably 2 imaginary out there. I'm going to teach you how to find some of the more simple imaginary ones. We're not going to do all of them because it can get very extensive. Once again, if you want to learn how to do this one from scratch without Desmos, go visit your friends in the honors class, and they might be able to tell you how to do it, but we do not have time to spend on that. So we are going to just do some of the more simple ones. All right, so let's talk about how to solve this with factoring. So first of all, let's just go ahead and address this. We could graph this, and in fact, graphing is going to help us a little bit. 4x to the third plus 4x to the second minus 24x. So I'm getting -3, 0, and 2. This is one that I could do by graphing, right? So I could get the answers by graphing here. I'm not saying that you cannot. However, there's a few different things that they might do. They might give you a question where they like ask you for the steps instead of asking for the final answer, in which case you're going to have to know how to do this by hand. Plus, I want to do one that's easier before we go to the ones that are a little bit harder. So, if we're going to factor, the first thing we need to do is move everything to one side so that the equation is equal to 0. Okay? That is already done for us. We do not have to do that here. Then we will factor out a GCF if there is one. Does this problem have a greatest common factor? What is it? 4x. So I'm going to divide out the 4x. And so 4x times, I'll have x squared plus x minus 6 here will equal 0. Okay, once you've done the GCF, step number 3 is to factor the remaining expression. You can use the graph to help you here. So I've got the 4x out here. I am trying to factor this. I know that I will need an x and an x here. You can. It's not foolproof to let the graph help you, but the graph can help you some here. If I look at this graph right here, 0, that's where the 4x comes in, right? But my other numbers are -3 and +2 right here. What's the factor that goes with -3? +3. It'll be x plus 3. And then over here on the graph, my other number is a +2, so that'd be a -2. If you look at this, you want to check to make sure it works, because there are some cases where this may not work. But I I've got a negative 6, so 3 times negative 2 does give me negative 6. And if I add them together, 3 and negative 2, that'll give me a positive 1. So that's factored correctly here. So we've already done the factoring stuff already for this. The last step on these is that they're not asking us just to factor. They want us to find where this equals 0. So we're going to set each piece equal to 0. It's almost identical to finding the zeros like we were doing the other day. We just say 4x equals 0. So if we divide both sides by 4 there, x is going to equal 0. We'll say x plus 3 equals 0. If we just subtract the 3 there, we get x equals negative 3. And we say x minus 2 equals 0. So if we add 2, x will equal 2. So we've got 1, 2, 3 answers, and we only were supposed to have 3 answers, so that should be all of them. Okay, questions? Okay, let's try another one. All right, so on any of these, whether we're graphing, whether we're doing, no matter what we're doing, we want to move everything to one side first. So I need to subtract that 27x squared and move it over here. Also, we typically like to write these in order from highest exponent to lowest exponent. So I'm going to put that 3x to the 4th first. Then I've got a positive 9x to the 3rd and a negative 27x squared. Now, graphing is our easiest way to do this, so let's pull up the graph and just see what it looks like. We got 3x to the 4th plus 9x to the 3rd minus 27x to the 2nd. All right, so I'm getting negative 4.854, 0, and 1.854. Those are my answers. Those are the answers. But it said to give your answer as an exact answer. Desmos has rounded off those decimals, right? It rounded it to 3 decimal places for us. So those are not what we call exact answers. When it says exact answers, what it's talking about usually is that there has to be quadratic formula, and your answer is like 2 plus or minus square root of 7 over 5 or something like that. So while the graph will definitely help us here, it is not going to be enough to get the final answer there. So we're going to have to factor to do this. And if we're going to factor, we are first going to look for what? Greatest common factor. And Angel, what number could I divide all of these by? 3. Can I take any x's with it, Angel? How many? 2. So, all right, so I've got 3x squared, and then 3 divided by 3 is just 1, and then I'll have 2 x's left there, so I'll have x squared plus 3x minus 9 equals 0. Now, we normally want to factor, right? So we normally want to try to do this. 3x squared, sets of parentheses right here. But what numbers do I multiply to get negative 9? Negative 1 and 9, positive 1, negative 9, 3 and negative 3, or I could switch where the negative's at, but it doesn't make a difference on that one. Do any of those give us positive 3? They do not. And when I looked at my answers on Desmos, I got decimals, right? If you're seeing those decimals, it means it won't factor. So this one will not factor. But that does not mean it does not have an answer we need to use quadratic formula. So first of all, I would set the 3x squared equal to 0. Now that is a very straightforward one to solve. You don't have to use quadratic formula there. You would divide by 3 first. That would just still give you 0. And then you would square root. But what is the square root of 0? Still 0, right? So 0 is one of our answers. We saw that one on the graph too. But the other part is x squared plus 3x minus 9 equals 0. And we said that part's not going to factor, so we have to use quadratic formula. What was quadratic formula? X equals. All right, it's, we'll say Miss Ball's chant. Opposite of B. You gotta repeat after me. Opposite of B. Y'all, come on. All right, I'm gonna write the whole thing first, so you'll be prepared. Y equals mx plus, oops, that's wrong. That's a C. All right. I need full participation here, okay? Because this will not be given to you, so this part right here is opposite of B plus or minus square root. B squared minus 4AC. B squared minus 4AC. 4AC. All over 2A. Alright. This, you got to know this one. I might let you use a note card on the test, but you cannot use a note card on the check-in. You cannot use it on the EOC. I can't let you do that. Like, I'm not allowed to. Even if I wanted to, they don't let me. Right? So plus this like keeps coming back up in other classes, so it's just good to know if you're going to have to go past this class. So our A is not there, but it would be a 1, right? So A equals 1, B equals 3, C equals negative 9. So to do this, we're going to have negative B. B is 3, right there, plus or minus square root. B squared minus 4AC, so B is 3 squared minus 4 times A. What's my A? 1. What's my C? Negative 9. All over 2 times A, which is 1. Because they asked for an exact answer, I'm not going to type this whole thing into Desmos because it's just going to give me the decimal I already had from the graph, right? So that negative 3 just stays right there. I just want to know what's underneath that square root. So 3 squared minus 4 times 1 times negative 9, which is going to be 9 plus 36 is going to give me 45, I think. All over 2. Jonas, I'm glad you made it back. Joseph has your papers for you there. Okay. Questions here? Beside Angel. All right. Okay, so this would be your answer, and it's going to be this and 0 is your answer. It's 3 different answers. But, oh, we're not supposed to have 3 answers. How many answers are we supposed to have? 4. So we have 3 real and 1 imaginary? Can I ever have 1 imaginary? No, they always have to be even numbers. So it's not 3 real, 1 imaginary. Let's look at the graph again. Do I have any double zeros? Where's it at? Right there in the middle at 0. Okay? So this one right here is a double. 0 is a double. So you only have 3 distinct zeros, but it's really 4 because that x equals 0 is a double. That's why it's good to still graph these even though you're having to do them by hand. Okay? Questions? All right, we got one more. I mean, they test it. I don't know how much. They don't tell me what's going to test very well. All right, last one. All right. Okay. What do we need to do first? Everything to one side. That's what we always do first. So x to the fourth minus 5x to the third. When I move it to the other side, it just changes signs, right? So even if I don't write, I'm going to have negative 10x squared minus 20x minus 56 equals 0. Okay? And then we are going to graph this because that will at least help us find our real zeros. So x to the fourth minus 5x to the third minus 10x to the second minus 20x minus 56. All right, and it's looking like we've just got 2. Negative 2, positive 7, right? So negative 2, positive 7. So if x equals negative 2 is our solution, what's the factor that goes with that? X plus 2. And I had x equals positive 7. What's the factor that goes with that? Negative 7. Okay? This is the only type of problem we're going to have to do this with. Okay? We are going to have to do long division. X to the fourth minus 5x to the third minus 10x squared minus 20x minus 56. Okay? You're going to use your factors, not your solutions. So you can use x plus 2 or x minus 7 first. It does not matter. I'm going to use x plus 2. What times x plus 2 will give, or what times x will give you x to the fourth? X to the third. Okay? So I'm having to do over to the side, x to the third times x plus 2. If I distribute that, I will get x to the fourth plus 2x to the third. That goes right here. Okay? So I'm going to subtract this. This will cancel. I'm subtracting negative 5 minus 2. It's going to be negative 7x to the third. I'm going to bring down this minus 10x squared. Okay? Then I'm asking myself, what times x would give me negative 7x to the third? Negative 7x squared. Okay? So negative 7x squared times x plus 2 is going to be negative 7x cubed minus 14x squared. So negative 7x cubed minus 14x squared goes here. We are subtracting, which makes this a double negative, which makes it add and go away, which makes this a double negative, and is going to give us 4x squared. I'm going to bring down. Okay. All right. What times x would give me 4x squared? 4. So plus 4x. So if I do 4x times x plus 2, I will get 4x squared plus 8x. 4x squared plus 8x. I'm going to subtract. This will cancel. I'm going to get negative 28x right here. I'm going to bring down my negative 56. What times x gives me negative 28x? Negative 28. Okay? So I got to do negative 28 times x plus 2. That's going to give me negative 28x. Negative 28 times 2 is 56. So that ends up being the same, and I've ran out of room, but it's the same, so I'm done right there. I've divided. Okay? So that means what I've got right now is x plus 2 times x to the third minus 7x squared. Don't pack up. We're not done. I said these are the worst. Okay? All right. We got to divide the next factor. Okay? Guys, if you were in honors class, it'd be so much worse than this. Okay? We're going to do this one hard problem. Stick with me. Okay? I'm telling you, we do a lot worse than this in the other class. So you can do one hard problem. Okay? Okay? All right. Okay, we're dividing again. What times x gives me x to the third?
X to the second.
X to the second. Perfect. X to the second times x minus 7 is going to give me x to the third minus 7x. So x to the third minus 7x squared right there. Goes here. I subtract. That actually cancels both of those, right? So then I'm going to need to bring down the 4x minus 28. What times x gives me 4x? 4. So I'm just going to have a plus 4. It kind of skips that middle term since those both canceled. So 4 times x minus 7 is going to be 4x minus 28. So that is going to be 4x minus 28 here. And when I subtract that, it just cancels away, right? So now what I have is x plus 2, x minus 7, and x squared plus 4. We already have the solutions for the x plus 2 and the x minus 7. They're over here. What do we need to do with this x squared plus 4 to find the zeros that go with it? We will set it equal to 0. We'll subtract 4. So x squared will equal negative 4. Then what do we have to do to get rid of a square? We will square root both sides. Oh, what is the square root of negative 4? 2i. And we'll have a plus or a minus with it because we square rooted both sides. So x equals positive 2i. X equals negative 2i. Okay. All right. So